Hi guys, I'm going to talk today about the probability of events. So we're going to recall for any experiment there's a set of outcomes, and the total set of possible outcomes is called the sample space, which we represent with a capital S and a set of curly brackets. So let's think about rolling a dice, a six-sided dice. My possible outcomes are 1, 2, 3, 4, 5, 6. And let's say I decide to define some event A that is rolling an even number. So I could also represent the event A as a set with all of the even outcomes in it. Alright, what's the probability of A? And you might be looking at that and say it's a half, Miss B. Of course it's a half the numbers are even. Yeah, it is. But how do we do it when it's more complex? So the probability is the frequency of the event divided by the total frequency. Now, we'd word that if we were doing experimental probability, if I was actually rolling a dice and watching how frequently I got an even number, I would word it like that. A different way to word it is n, so the number of outcomes in the event, divided by the number of outcomes in the sample space. And I would use this wording for theoretical probability. So here we're talking about theoretical probability. I'm not actually rolling a dice. I'm saying what should the probability be. So the number of outcomes in the event is 3. The number in the sample space is 6, and that simplifies to a half. That's how you find the probability of single events. We've assumed here that it's a fair dice, that each one of these outcomes is equally likely to happen, and that's the only way that this formula works. If we don't have a fair test, then we have to have a different method.